So this question is directly coming from Feb March 22, paper 3 variant 2, and this is the first part of that question. The remaining parts were with respect to the numerical solutions, so that is why I'm not involving in this video. So this question is about sketching the graph to show that if I plot this graph and this graph on the same axis, we have to show that there is exactly one root in the interval of 0 to pi, where pi is not included in the domain. So let us think about how the graphs are going to look like. First of all, let's think about sec of half x. So to draw the sec of half x, you should be understanding how to draw cos of half x. If you know how to draw cos of half x, then sketching this becomes very easy. So half basically indicates that in between 0 to 2 pi, you will have half the curve. So in between 0 to pi, you will just have 1/4 of the curve like this. And if you're having this kind of a curve for cos of half x, so you know that the graph is going to look like this for the sec of half x in between 0 to pi. So if I just go ahead and try to plot this, of course you don't need to be exact. You can see you are drawing your graphs not to scale. So this is my y-axis, and let this be my x-axis. Let's call this 1 on the y-axis. Let's call this pi. Let's call this 0. So my graph is going to have an asymptote over here for the sec of half x. So it's going to look something like this. It's going to look something like this. Let me just draw it like this and call my pi over here and not over there. This looks much better as compared to what I was about to draw before. But yeah, this is your asymptote over here for the sec of half x. You always need to plot your curve and label it. So this is y is equal to sec of half x. Now what about 4 minus x square? I know that 4 minus x square is nothing but the minus x square curve, which is shifted up by 4 units. So it's going to look something like this. Okay, at 4 we are going to start and it's going to come down something like this. Let's see what is the value of y when x is equal to pi. So 4 minus pi square, it is minus 5.869. So let's say this is minus 6, minus 5, minus 4, minus 3, minus 2, minus 1. So it's going to look something like this. Of course, it's a quadratic curve, so it's going to look something like this. So these are the curves that I've drawn in between 0 to pi for both 4 minus x square and sec of half x. And we can clearly see, of course, I need to label this. This is y is equal to 4 minus x square. And in between 0 to pi, I can see that there is only one intersection. You can just write a conclusion. The graphs intersect once between, of course, you write it properly. I'm just writing it in the short form, between 0 to pi. Or you can write 0 less than equal to x less than pi. Hence, one solution. Hence, only one solution or root as asked in the question. Now, if I just want to show this to you, how it's going to look like on Desmos so that you can be comfortable that, yeah, my graph looks very similar to what it should look in real life. So let me take you over the Desmos. So on the Desmos, I have plotted sec of half x in between 0 to pi and then 4 minus x square in between 0 to pi. And you can see that it is matching our expectation that in between 0 to pi, sec x is going to go like this on the upward direction, and the 4 minus x square is going to look like this in between, of course, 0 to pi, and there is only one solution in between that.